pleasure to introduce you to Tom Burns, who's the Director of Post-Production Infrastructure at Technicolor. Tom?
And thank you to the Ontario Centres of Excellence for putting on this event and hosting us as a panel. This is quite a milestone in 3D research and presentation in Ontario. To start the panel, I'd like to ask the very basic question of why bother about non-entertainment applications of 3D? I mean, isn't that boring? Isn't that kind of dumb? But if you look around, especially the Ontario Centres of Excellence, focusing on manufacturing, for instance, there's huge applications for 3D technology in capture, in analysis, and in output. And so these are the kinds of things that we're going to be talking about and relating to a number of non-entertainment industries that have kind of been early adopters of 3D technology, either in the capture or the analysis or the output areas. And notably, I think oil and gas, with their ability to interpret 3D geophysical information when they're doing seismic survey, looking for oil. Big Pharma certainly has been a pioneer in developing 3D analysis technologies when they're getting in and doing designer drugs molecule by molecule. You know, the orientation of a molecule, if it's on this side or if on this side, has a tremendous impact in whether the drug is successful or not. Manufacturing, I already mentioned, is a big one. The Centers for Excellence in, is it Waterloo? Excuse me, that does the 3D printing. Have people seen the 3D printing, stereolithography, and laser sintering, and the one that does, they cure a polymer with this UV laser. I forget what the third kind is called. We'll talk about that a little later. And the fourth one that I wanted to mention is medical visualization, and we have some specialized expertise on that. So as we talk about these industries, these technologies, and how they go beyond entertainment 3D, I'd like us as a panel and the audience to consider whether, there's kind of two questions I'd like you to consider. And one of them is, where do you draw the line between what's an entertainment use of the technology and a non-entertainment use of the technology? We'll get into some examples of that later. And as a corollary to that same question, who's driving the innovation? Does industry look at cool things that are happening in the cinema and the gaming world and adopt those to make their industrial processes better, faster, cheaper, whatever? Or do the industrial users of 3D research and develop the technology, and then entertainment just gloms onto it and starts using it because somebody else has done the legwork? So that's a couple of questions to ponder as our four panelists make their presentations, and then we get into a general discussion. So to introduce our panel today, I'd like to bring first up Michael Page, Assistant Professor in the Faculty of Art at OCAD. Welcome, Michael. Next to Michael is Ihor Petelycky. He's General Manager of Core Technology and Applications for Spatial View, a company that's pioneering the delivery of stereo 3D content and also autostereoscopic technologies. Do you know what I mean when I say autostereoscopic? No glasses? The funny thing is, when talking about stereo, audio people think you mean this, 3D computer animation people think you mean this, and digital cinema people think you mean this. So stereo is one of those words that we always have to qualify. S3D seems to be what everybody uses as an acronym these days. So beside Ihor is Dr. Paul Salvini, who's Chief Technology Officer and VP Canadian Ops for SideFX software. SideFX, of course, being one of the three darlings of Canadian software well before the .com era, back when it was called high tech. And welcome, Paul. And completing our panel is Shawn Veltman, who's Product Manager with IC3D, a technology company focusing on single lens capture for medical and industrial and electronics applications. Thank you, gentlemen, for being part of the panel. And I'd like to begin with brief presentations from each panelist. So let's kick off with, oh, I'm sorry, I did this wrong. I totally sat you guys in the wrong order. Forgive me, pilot error, pilot error. Ihor is going to begin our brief presentation from each panelist. Forgive me, do you want to just pass the mic over there?
So
I apologize.
Okay, hello? So I think it's good that I'm speaking first because I have no visuals with me. Auto stereoscopic displays do not require glasses and don't work on these systems. So all I can say is we're at booth 330. If you want to see any of our technology, feel free to drop by and take a look. Just to do a very short kind of shameless self-promotion, our company was formed in 2004. Our focus was auto stereoscopic, both two-view and multi-view displays. Basically the difference being single user versus multi-user viewing. We designed and manufactured displays over a period of time. We shifted away from the hardware as we realized that content creation, content adaptation, content distribution was where our real potential value add was. So we've basically morphed into a software company, and a lot of our products are related to that area. What I wanted to talk about in terms of the non-entertainment aspects of Stereo 3D is there's a very fine line between entertainment and non-entertainment, but I wanted to basically delineate kind of non-theatrical, non-broadcast from other uses of 3D, which I still think will have a pretty significant impact on the population at large. I've got a piece of paper with me because I'm also going to be throwing some numbers at you just so you get a chance to understand the scale and the scope of these other devices. So general consensus is there will be about 125 million 3D enabled TV sets sold by 2014. That's pretty straightforward. What's significant is there's a big trend now to this concept of a connected TV, where you have a browser and widgets built into the TV and an internet connection, and there's an alternative channel to get content which is non-broadcast, non-theatrical. So that's one area that I think has a pretty significant, or will have a pretty significant impact on 3D. 3D enabled capture devices. Fujifilm FinePix cameras have been around for a couple of years now. They're into their second generation. They capture very high resolution 3D images using two lenses and HD video. Very popular among photo enthusiasts. Sony with their CyberShot cameras are now all shipping with a single lens solution that has, through software, a 3D capture capability. A company called GoPro, which is very, very popular with kind of skateboarders, snowboarders, all the extreme sports guys, have a 3D camera rig that's HD that's available for $700. And they have right now over 280,000 followers on Facebook, literally hundreds, if not thousands, of 3D videos on YouTube. And there are a lot of other consumer video cameras coming out. So the point of this is user-generated content. This stuff is cool. It's easily viewed on a variety of different devices. The ability to create that content is relatively inexpensive. So that's a big area that I believe is going to also drive the adoption of 3D. 3D enabled gaming, the Nintendo 3DS was mentioned, and yes, it is a gaming device. However, it does have a stereo camera and it is internet connected. So it is not just a gaming device, it's a content creation device, and it's a content distribution and sharing device. So imagine starting to take pictures with your Nintendo DS, sharing them with other Nintendo DS users, and them seeing it in 3D. Numbers right now for projections of Nintendo 3DS are around 70 million units by 2015. That's a pretty big installed base of a 3D specific device. 3D smartphones 60 million units projected by 2014. And again, for viewing content, for creating content, for sharing content. On the visualization side, which I'm sure some of the others will also talk about, John Petty Research says we'll have 75 million 3D PCs to be shipped in 2014. And once you have those PCs on desktops, relatively inexpensive compared to standard PCs, engineering, architecture, medical and pharmaceutical, industrial design, everything becomes feasible in stereoscopic 3D. Another area is public venues, what we call digital signage. So that's an area we've been involved with at the 2010 Olympics, where at Ontario House over the bar, we had running 3D content, which got a lot of attention from people. We worked closely with Sheridan College to use autostereoscopic displays in a 3D game environment with Blackberries as controllers. That was also extremely popular. We've taken commercials, many shot by James Christopher, adapted them to multi-view, be able to put them on public display using glasses free. And as James said about commercials, in a public environment, a 3D display has a pretty significant impact. It stops people and they will view the content. Applications we've been involved with, point of sales with companies like Best Buy who want to promote 3D products, but you don't want glasses either disappearing or not available, etc. Trade shows and conferences, I mentioned the Olympics, and then also product demos at trade shows, BMW, Porsche, etc. We're also now, because of our multi-view generation technology, embarking on the 3D print side. And again, now we're going to have to differentiate 3D printing from lenticular printing. Lenticular printing is what we're talking about, where we generate multiple views, we print them on the back of a lenticular film, and you get the 3D effect by viewing the image basically from a flat surface. Applications, and again, very popular in Asia, not so much in North America, but we expect to see it coming here as well. Trading stickers, security labels, even large format art prints, and we're seeing more and more consumer printing. And for example, in China and Japan, in Korea, to have your wedding photo done on lenticular in 3D is not very uncommon. Finally, one area that is not as broad but an interesting application of 3D or stereoscopic 3D was we were approached by McGill University, who had come up with this idea of using our autostereoscopic display for mobile to develop a therapeutic application to help both kids and adults or to treat amblyopia, which is lazy eye, which if you sat through 2 sessions ago is one of the big barriers to viewing stereo 3D properly. So in this particular case, they just developed a very simple Tetris-like game. If both your eyes are working properly, you actually see the pieces coming down. If the eye that is not working properly isn't in the right position, basically the screen goes blank. So the motivation is to try to keep working both eyes in tandem so that you can complete the game. They've gone through an initial trial. They've published a paper. They're going through their second trials, and they expect to launch this product within a couple of years. So that's a slightly different take on a non-entertainment approach to 3D. And I think that's it for me.
Very good. Ihor, thank you very much. That was a great overview of different technologies in different markets. Next up, sorry for the false start there, Michael.
That's quite all right.
Next up, Michael, your presentation. And you have clips as well?
Sure. Well, I teach both at the Ontario College of Art and Design, and I'm a visiting professor at the Institute for Optical Sciences. So our alternative uses or non-entertainment uses of 3D technology are in the field of 3D visualization and making art, which we clearly make distinct from entertainment. But I'm going to talk about 3D visualization. If we can change the slide. Some years ago now, about 11 years ago, before bioinformatics was called bioinformatics, scientists came at us from the, this is the National Library of Science project, the Visible Human project, and scientists from the University of Michigan came to us and said, you know, we've got all this 3D data, can you print this, take this data, create 3D images and then print them holographically, which we did over the course of the next 2 or 3 years. So we have the video of the visible, this is the visible woman. So they came at us, a bunch of artists, with these thousands and thousands of slices of human tissue, all at 1/3 of a millimeter resolution. So when we finished throwing up into our hands, we started to work with the tissue samples, and the first thing we did was to create an exostructure for the visible woman, and the scientists cautioned us that this was a donor. You know, it couldn't look like your Aunt Matilda or something. But we then went on to build geometry around the tissue, and much improved from this early work that is intended to be used in training young physicians and surgeons and med students in anatomy, because the geometry was taken exactly from the tissue samples. We have the next slide, please. Again, Professor Miller at the U of T was having difficulty explaining how myoglobin, this, we can roll the video here, myoglobin is this molecule, blood molecule that constricts when it's oxygenated and relaxes when it's depleted of oxygen. And in this heme mechanism that you see in the center and the protein strands, no one's seen that, of course. So 3D visualization is about visualizing things that can't be seen. They're either too small or too quick or something like that. Next slide, please. This is the Ontario Science Centre, who came to us with all the information they had, which was this, on what a atomic force microscope might look like. And we can play the video. This is a stylus then skating across the surface of a bed of carbon atoms. And of course, they deflect a laser beam off that atomic force microscope in order to scribe out the profile of that bed of carbon atoms. Next slide, please. So we got a little bit frustrated with the holographic process. The digital holographic process is a thing that only works with data from 3D. So if you're someone who can work in 3D animation software, you can, and I've been doing that for about as long as there's been 3D animation software. I'm still not very good at it. It's a very expensive process, and it was a big barrier to the use of holographic technology. So we developed this next device called the RAIL, and this is a bit of a stretch. It means the real world, what is it again? Image acquisition and image liaison, there you go. And the idea was to make a thing that could go anywhere in the world and record holographic scenes that were camera ready, and then these images would be FTP'd to this home office in Toronto and Service Bureau and then shipped out via FedEx. At least that's what we told OCE, and they funded us, and we did it, damn it. Thanks very much. So here, Margaret Atwood, author Margaret Atwood, agreed to, you can roll the video, to sit for this initial portrait. We're having a little trouble with the video. It's not actually completing. There we go. Almost. One more time. And we had a bunch of proposals for Margaret, and she dispensed with all of that right away and said, why don't you put me into a tropical rainforest and have a tropical bird land in my hands? And so we did that instead. We can see the next slide. You'll see the composite here. One of the things that the RAIL device does is it provides the metadata that allows you to take that 3D environment that's synthetic and comp it together with the real world imagery and create what you see in the hologram, which you'll have to go to booth 8 something. We're in the 800 row there. You'll see the Atwood hologram, or at least the first prototype. We could change the slide again, and then I love coming to talk about this work, but you need to know that there's a whole bunch of really creative, hardworking people that actually do the work, and there they are, and there's some contact information. We are now working on a marriage of haptic technology and holography. This is holography that you can touch, so we'll superimpose the haptic map with the CG elements that go to create the hologram, just like the Atwood one, only you'd be able to, in the haptic environment, go up and poke her in the cheek or something like that, and actually feel that environment. We're also working on a video interactive a thing that will work with 3D graphics and digital holography and be interactive, and I can direct you to a place to go and see that. The reason I showed you the earlier 3D visualization projects was that I believe the answer is that the industry has led entertainment into where they are today. But now we'll have a look at some work that we're doing here with our colleagues from the Junction, our collaborators. This is their project that they did for the Olympics, demonstrating, and you'll need your 3D glasses on for this, folks, demonstrating what happens to athletes when they get injured in Olympic sports. And so this one is around hockey players, and if you saw the impact that's shown prior to this of the real footage, you'd see that this is probably exactly what happens to the human brain. And of course, so how else do you demonstrate that except to show it as a 3D visualization? So it's my impression that 3D visualization, apart from being entertaining, or 3D imaging, apart from being entertaining, will be the thing that entices Canada's smartest and best people into areas of study and research that are meaningful and directed. It's also a way for me as a researcher to describe what it is I'm trying to do to grant givers and government and industry, and it's also a way to promote interest-based research, because how else do you get your idea across to people who might support it if they understood it? I also think that 3D visualization is a celebration of research. It's a way to share with the public, the taxpayer, students, what it is you've been doing, what your hard work means and where it went. So
fantastic.
Thank you.
I can't honestly think of anything more cutting edge than haptic holograms. Are you kidding me? People know haptic is sense of touch, right? So this is something I haven't even heard of before, and I hope we can hear more about it. Next up is Paul Salvini. You have stuff you want to clip and roll right into?
Yeah, absolutely. We'll go ahead and start with Mars.
Fantastic.
So the first clip comes from Jed Schwartz. This is in 2D, so sorry, no 3D glasses required. Of course, it's all created with 3D software. This is the Mars Spirit rover being recreated, and what I thought was neat about this was done for the National Geographic Channel, and my son was watching this, and he says, "Daddy, I want to take it for a ride. Can I drive it?" And what's neat about that, being his first instinct, was, of course, what an amazing way to allow someone to experience something like the discovery of Mars in a way that is a little bit more interactive, a little bit more immersive. And of course, when you think about the 3D experience in film and what we try to do in the 3D world, it's how do we create a more compelling, immersive experience for the viewer? And what was really exciting about this one is you can truly imagine seeing this in 3D, being able to drive the Spirit rover around. And of course, I had to explain to him, no, you can't. It's like, please, Daddy. It's like, okay, well, maybe I can arrange that, but. And so then once we got him to play with being able to drive things, then he wanted to know whether he could actually control the one on Mars, because that would be even cooler. Okay, so can I control the Mars rover from here? Which you can't do, but again, you can imagine in the future kids across around the world being able to explore an area make their little submission and actually do something like that, where you do control a mission and really make it a little bit more engaging, a little bit more participatory. So that's it for the first one. The second clip I want to show, this one you can put on your glasses, although it is only a screen capture, but this is some work we did with a local hospital in Toronto. And since I'm glad I didn't bring the only gross thing today, so this is surgery being done for laser ablation of a tumor within a prostate. And in this case, you can see there are 3 tumors within a prostate. And in this process, you're going in with a fiber optic tip and you're burning a tumor. It's like cooking a steak. You're burning a tumor for a certain amount of time at a certain temperature in order to destroy the tumor. And the visualization is, as the tumor is burned, it disappears, and you can actually see that. What's neat about that is again, you can imagine the implications here because of the immersive nature of 3D, is when we're training the next generation of operators to do this kind of procedure, because it won't need to be done by a highly trained, expensive surgeon. You could imagine this is a very immersive way. It's a very fun way. You can almost turn this into a game where you can load up 50 cases or so and see how quickly you can treat these cases, and with what precision you can treat these cases. And it turns out, after playing with a simulator of this kind, you actually quickly become very proficient at this type of procedure. And again, I think what's being added here is that immersive nature of being able to see it, try it. You want to go there, and it's really becomes like a game where you want to see if you can do the operation faster or in a better way or in a cleaner way, et cetera, et cetera. So for me, beyond entertainment means taking the same experience we're trying to design in the entertainment world, which is that really compelling, immersive experience, and bring that to the world of education, bring that to the world of training, and get that engagement that gets people glued to doing what they're doing, and that experiential learning that lasts a lifetime.
Thank you, Paul. I didn't find that gross at all. Wait till we see Shawn's endoscope stuff.
Lucky you. Okay. So I'm with a company called IC3D. We specialize in research and development of single lens stereoscopic image capture, or single lens 3D. So what we've got up on the screen, you can put your glasses on. These are images taken from an endoscope. It's a 2D endoscope that's been modified to utilize our single lens 3D technology. That's a red pepper, for those who are wondering, luckily. So I've got some pictures and video. What you'll find most useful is to lift up the glasses and then see the same scene with the glasses on and off. And just notice the difference in the depth information and depth perception that you get with the glasses on. It's, to me, the best way that I can think of to describe just how useful it is to have 3D in minimally invasive surgery. You know, as a medical professor from Emory University pointed out, the last thing that you want is to bump into something because you didn't realize how close it was. And that's where this really comes in. This topic itself, the idea of going beyond entertainment for 3D, it's something that's near and dear to my heart. I talk about it a lot when I'm describing what we do, simply because when you think about it, as many differences as there are, the processes are the same. You know, you're capturing, at least for stereoscopic images, you're capturing images, you're putting them together into a single stereoscopic image, and then you're viewing it. So, you know, you might be at a movie theater watching a 3D movie, and if there's some vertical misalignment, you're going to hurt. What's that? Can you switch the...
Swap eyes?
Swap eyes? Either that or just turn your glasses upside down.
Don't do both.
Yeah. Anyway, if you're at a movie and you see some vertical misalignment, it's gonna suck, and your eyes will hurt or your head will hurt, and you'll leave. And it's a bad afternoon, but that's about it. If you change the context, though, and you're a surgeon in a medical theater, and you've got a 4 to 6 hour operation, and a half hour in you realize that your eyes are hurting or your stomach's upset, you've still got 4.5 hours to go and you're not at your A game. It's completely unacceptable. We can't have that. And so that's one of the areas that we spend a lot of time in looking at. What causes discomfort. You know, why does it happen and how can we get around it? And what's really interesting is that the causes of the discomfort are generally the same for entertainment or not, because it's the same processes. You get things like horizontal, rotational, and vertical misalignment. You get things like color mismatch. You get things like synchronicity mismatch. You get things like zoom and focus mismatch. And these are all things that can cause artifacts, and these are all things that can cause 3D to not be very fun to watch. And these are all things that come up because of the process of capturing 3D through 2 cameras or 2 lenses. So what we did was we said, well, why do we need that second lens? You know, 3D is not about having 2 cameras or 2 lenses. It's about having 2 images with disparity. And so by being able to capture separate images through a single lens, we're able to cut out most of the problems at the knees. You know, in the entertainment world, these are well-known problems, and there's well-known solutions to get around them, usually involving post-production or software correction. And that's great. You know, you can add some extra money or time on, make it up in DVD sales later, and everyone comes out happy. But if you need real-time feedback, even with software correction, you might be adding in a temporal delay of a quarter or half a second, and that's really not good when you're talking about surgery. So what we've really been aiming to do is to capture very comfortable, very useful 3D for real-time display that you can look at for hours without it affecting you. One of the happy benefits, of course, as a side note to single lens 3D, is that you're able to reduce the size of the device you need. So you can cut the device size down by 50 to 70%. And when you're thinking about endoscopes going inside of you for medical procedures, smaller is usually better. And that's about it for me. Yeah, you know, we're always interested to talk to people who have novel 3D capture needs, and you know, I think there's 3D. It's a fascinating field, and I think there's so much more to do.
Thank you, Shawn. That's fantastic. Michael weighed in first with his vote that industry is driving entertainment, and I think when I think about the entertainment possibilities of single lens capture, I mean, Rob, how good would those underwater shots have been if we'd been able to have, you know, not the normal entertainment type of rig that we all know and love or hate? So yes, so in this case, we have one more vote, I think, for innovations in industry, in this case, real-time medical imaging, that I can see the entertainment industry glomming onto because it solves a particular problem of getting that shot that the director particularly wants, and it's maybe too tight a fit to get a traditional rig in there. Although, I don't know what's going to happen with the GoPro HD little rigs. Those are fun, but they have an awful lot of ways to go before we can, you know, stand to watch a full feature in GoPro HD format. So if we're on the topic of capture, if we can see that single lens capture has some amazing advantages to it, I want to actually step way back and think about stereoscopic stills capture, which has been around since before the turn of the century. As far as I'm aware, Matthew Brady, the Civil War photographer, did the first set of, you know, those things you can find in antique markets sometimes, the wooden stereo viewers. And then following hard on his heels was, of course, Edward Muybridge, the guy that did the motion studies. He was actually a stereographer before he and here's another case of industry driving entertainment. The industry in this case was gambling, right? You guys know that the famous picture of Muybridge was to settle a bet as to whether all four hooves of the horse were off the ground at any one point. And he had to use, I think it was 12 cameras in a row. And of course, that technology of multiple cameras takes us in a straight line right to the bullet time effects from the Matrix, which were also done with a very large array of single images to simulate 3D. And so on the acquisition side, it seems like single lens or anything that can get us away from the complexity and cost of multiple cameras, synchronization issues, lens color matching issues. I mean, the list goes on and on and on. Is something that obviously entertainment users are going to glom onto as quickly as possible. What other kind of capture issues? Because I'm dividing the whole world into kind of capture, analysis, and output, and we're starting with capture. So I open it up to any and all members of the panel for comments on capture. Michael,
Thanks.
you've got the rail. You want to go?
Yeah, but I think if you look at the technology of Areas 3D here in Toronto, I'm pretty sure it's the best technology in the world for capturing artifacts. And so they're doing RGB point cloud captures that are incredibly high resolution. And that, again, is all about data and three-dimensional data and building the world's largest library of 3D data, human bones, you name it.
Yep.
And so I think that's an example of where industry is creating the super high resolution capture of artifacts and replicating them in ways that are important so that...
And that's primarily for bioinformation, medical geometry, if you will.
Well, no, 80% of Canada's museums are in Ottawa, and 80% of the artifacts that Canadians own are in storage. And so if Canadians had artifacts that they could explore online in 3D, the way that area stuff works, it's incredibly high-res stuff, then that would be a way to distribute cultural artifacts, for example.
Would you distribute them the way that Google 3D Warehouse is an online repo for 3D objects, or would you make it like a VR? Remember VR? Everybody remember lobster people wandering around like this in virtual reality? Or would you make it kind of a net-based tourism destination where you could experience something along the lines of what VR was supposed to be?
Yeah, I think young people, should have access to Champlain's Astrolab if that was actually his Astrolab. We don't know, but the artifacts that are in museums, you shouldn't have to go to Ottawa to see them. So young people, researchers should all have access to that stuff in high res and 3D.
I'm jumping around here a bit, but when I talk about people going to see it versus having it transmitted to them, the concept of holography, or of, let me ask Ihor this question. Is holography the ultimate goal of an autostereoscopic system?
Yeah, I think...
Or both of you, either of you, sorry. I'm jumping around.
Certainly, I think these are kind of phases that we're going to go through to achieve something like holography, where we get rid of the screen altogether. And even when we initially started talking about 3D on mobile, I mean, so many people came to me and went, oh, so that's like in Star Wars, Princess Leia floating above the screen. Well, not quite yet, but certainly that's where we want to go. And when we heard the first session yesterday, I think the general agreement is that for mass adoption of 3D, glasses have to go. It has to be glasses free. And then once we've achieved that milestone, I think the next milestone obviously is the screen's got to go.
Well, that's your haptic holography, is it?
Yeah, I think science fiction shapes a lot of what we do, and so the holodeck, people have just been waiting for the holodeck, and they're not going to be happy till they have the holodeck. And so in the holodeck, you can touch holograms.
Yeah.
So that's not our motivation for doing it, obviously. We see medical training applications and the like, but I think that, holo video has been around for a very long time. The credible workers at MIT who are doing this, and there's a lot of stuff online that's just not holography and it's not honest in any way, but Michael Lucente has just released a paper, and we haven't seen the results of it, of holo video, which is supposed to be the next generation. And as soon as we get the computational power, the spatial light modulator, and the bandwidth to move that stuff in between, we win. How you make that audience size viewable, I don't know.
Yep. So we've been talking about acquisition just of image, but another big part of 3D, especially this kind of 3D, is capture of motion. Now, Paul, your company's been doing mocap, interfaces to mocap systems since they were around. How important is mocap for non-entertainment? Like, I'm aware, for instance, of the kinesiology lab at the University of... Here, there's another reference back to Muybridge. The kinesiology lab was the first kind of industrial application of mocap for sports medicine and for fixing golfers' swings and whatever else they do. So give me some examples of how the temporal aspect of acquisition is relevant here as well.
Yeah, I think two things. One is everything we do as a software company obviously is in 3D, which is what's neat about that. So
You mean this kind of 3D?
Well, yeah, that kind of 3D, but what's great about that is, of course, it makes it very easy if you have a stereoscopic display. Just you plop down a stereo camera instead of a single camera, and play with the parameters, and off you go. And so it actually makes a beautiful test environment for trying out some of these issues with respect to, you know, what happens when you try to make a stereo film, you know, using real-world cameras. You can try all of that out in the virtual world before you actually go into the physical world. So it does create a beautiful lab for doing that. Obviously, what we like to do is to have a real 3D environment that you can walk around and you can explore. And you know, Christie's done that in Waterloo at the Hub with the Hive. They've set up, you know, with the 12 HD cameras. It's just absolutely beautiful. You can walk in, you put on the glasses. It's tracking where you're looking and where you're moving, and so it's a combination of motion capture technology with tracking technology with 3D stereoscopy to allow you to really explore in a volume, a 3D volume in an interactive way. It's as close as I've seen to that holodeck.
Right.
It's pretty cool.
I haven't seen the Hive myself, but remember back in the old days when SGI had the Cave.
Right.
So instead of being real-time input a la Shawn's system, this was all synthesized, not even modeled, just procedurally generated data, but you could walk around actually inside it, and that was a big deal. Oh, I'm dating myself here. We're going back 20 years. Yeep. Is the Hive a natural extension of that 3D Cave?
It is, and I think the big change is the quality of what's able to be produced today in real time is simply amazing. And so when you go into an experience like that, you're talking about not only a photorealistic experience, but you can have all of the additional depth cues that go with 3D.
Yes. That's
far more important than just separation. So there are many things we use to you know, indicate depth. And so we want to make sure in that environment that you can replicate those other factors as well to lead you to a much more natural, immersive feel.
This is maybe why industry has a bit of the edge here, is because GIS or mapping systems or something like that, they have layers upon layers upon layers, additional channels of information, heat channels, physical obstruction channels, legal rules. You know, you can't put like a propane line through your house or whatever. I'm just making this up. Could we, in the context of Google Earth, say, could we imagine that 3D is just one more tag, one more channel of metadata information that informs our understanding of the world through something like Google Earth?
Yeah, absolutely. So I think it's the natural world. Like I say, it's the one that we normally work in. 3D is just our native world.
Yeah.
We're now having to map it to 2D in order to, or you know, stereo 3D in order to deliver that experience.
Right.
But there's no reason why you wouldn't just leave it as a complete 3D world that people can explore. So I don't know that it'll be quite as easy as a tag, but there certainly would be native 3D formats that one could explore, and viewing through one's perspective would get those beautiful photorealistic things like depth cueing and what you're focusing on, and those kinds of effects that give you that photorealism.
So, Shawn, when a surgeon is looking through your device, they basically have two channels of information, the stereo. Do they have additional channels of information? I don't know. Audio cues, squishiness, I don't know. You know what I'm saying? Because that, I think, is relevant to the Hive that you're talking about when the acquisition happens in real time.
Exactly, and you can put all
Go
kinds
closer to the mic.
Is that one?
Yeah,
there we go. You can put just about anything you want on top of it, right? You can talk about the augmented reality and adding on almost.
Can I interrupt just 1 second?
Go ahead.
AR, who's played with augmented reality games on 3DS? Okay, sorry, go.
No problem. You know, it ties in though to another thing or another trend that I've seen, which I really like, is this idea not of competition between non-entertainment and entertainment, but of the marriage between the two. And that, you know, something is created and it has no entertainment value or no commercial value, but technology updates and it allows it to be used in that entertainment sense. I mean, think of GPS, you know, originally designed as a way to track Sputnik. You know, the technology for GPS came out of that, and now it's something that we have in our cars or our iPhones or whatever. And 3D is the same way. You know, it wasn't until we were able to get pervasive 3D displays that a lot of great work in 3D has been able to be done. You can get 3D TV now into a lab to visualize microscope images. You're not hunched over a dual port channel to see the cells. You can share it on a large high-def screen. And it's because we've been able to commercialize that technology that we're able to come back and use it again to get the next generation, the next iteration of the non-entertainment field.
So this question that I'm trying to answer then is not actually one way. Things might start out in industry, be popularized by entertainment, and then get fed right back into industry again. Here's a story I want to share with you. Everybody remembers, well, not you young people, Viewmasters, right? Remember Viewmasters? The convergence problems associated with Viewmasters are insane because you're looking at a positive, Kodachrome positive about that big, positioned about this far, maybe this far from your eye. So you can get away with a really, really wide divergence. Divergence. And then when you take those images and try to do anything with them, like put them on a 22-foot screen, it's instant super brain hurty. That's the technical term. So the software technology to repurpose what, vast amounts of Middle America in, a certain time period, 40, 50 years there, thinks of as 3D, is unusable for modern digital entertainment applications without some really seriously hard work. And I've been talking with some of the computer scientists here at the show about just how to approach that problem of reconverging images. Because it's always easy to take something that's converged for a big screen and go down. It's really hard to go the other way. I tend to ramble a lot, as you've noticed. I lost completely where I was, but I want to talk about the cave, the SGI cave. I haven't seen the hive. I should get my ass out to Waterloo and see it. But one, the stereo theory that came out of the cave, the SGI first virtual reality chamber that I'm aware of, that theory informs pretty much all of the stereo depth budget calculators that are on the market today. I mean, that's where they basically figured out what was super brain hurty and what was not. I really appreciated the optometrist or ophthalmologist. I always get those guys wrong. The guy in the panel earlier today who had measurable data of people, what worked and what didn't. Obviously, when you're calculating your stereo depth budget, be it for a medical viz or other kind of sim, be it for a GIS or other kind of mapping, you have to be as conservative as possible and super conservative, like you mentioned, for the doctor that's going to be having this thing on for 8 hours a day. But I wanted specifically to ask about architecture, because as far as I know, the technology, the first commercial use of that SGI technology from the cave, do you remember? This was a SIGGRAPH paper probably 15 years ago. The tower, that tower that they took multiple still images and were able to recreate the 3D geometry well enough for it to suit at film res. That was some really good algorithms there. And I'm hoping for a lot more of that research because, again, if we're going to close the loop from entertainment back into industry, I'd love to browse Google Earth, with or without glasses, don't know. I'd love to browse Google Earth for clues about, what's happening in the world. So that's why I think closing that loop is important.
Maybe I could just add quickly
Sure.
that, one of the neat things about the relationship between the entertainment world and beyond entertainment is if you look at the research community, the entertainment world moves so quickly into 3D that we weren't sure about the whole issue of, is 3D always a more compelling experience, and for whom is it a more compelling experience? Is it the same experience whether you're old or young? Is it the same experience depending on the type of content, etc.? And one of the opportunities for industry here and for researchers here is to, and part of this is being done right here in Ontario with 3D Flick. I know ARC Productions is part of it, and a number of the others are, to do the research to actually answer some of those questions, in a timely manner, but also a little bit more scientifically than just the buzz and the wow of, I saw it in 3D and it was really
Right.
cool.
Box office is not the only metric.
That's not the only metric, especially for scientists. And I think the other challenge with 3D is there's really good 3D and there's really bad 3D, and we have to, unfortunately, it gets all the same label. And so until such a time emerges as we get these standards to say, yeah, go see this 3D film, such a very good, versus that 3D film, which is, this horrible, post-production hack, not done very well, or something to that effect.
Yeah.
It's hard. So I think the research opportunity is huge, and that's not necessarily an entertainment thing. It's definitely beyond that, because it applies to everything that we do. And as you say, it came out of things like what was done. I think that was 1996 in New Orleans. Yeah,
that's right. So Ihor, talking about the difference in age ranges, do you have data on the kinds of content that people download from your site, how old they are, things like that? Is there a difference in age ranges as to, because Michael, I assume the research community is not full of teenagers, for instance. So we don't have a lot of age data, but I'm thinking that you have the widest spread of age data of any of us on this panel.
Yes, we do, and the unfortunate problem at this point in time is the age data is driven by the device adoption and not by the content.
Gotcha.
So if it's an iPhone user, we have pretty straight demographics as to who's buying it, and certainly they're at that age group. The one comment I did want to make, though, is when we're talking about entertainment, non-entertainment, etc., there used to be a Kodak commercial whose tagline it was because it's your stuff. And we can talk about great 3D and not great 3D, etc. And I think for television and for theatrical, that's really, really important. But you know what? If you've got a photo of your baby, it's the best 3D there is.
Yep.
It doesn't matter. And I think that's a whole area when we talk about GoPro or cameras or these kinds of things. Content is still king. And 3D is cool, but where I think we're going to see a lot of that kind of adoption is just taking my cool stuff and sharing it with either family or friends or a community of skateboarders, snowboarders, etc. I think there will become a pretty significant difference in terms of what is considered good 3D and how 3D is used by what I would call user-generated content, and then by industry and their requirements, and by theatrical and broadcast.
Good. Michael. Martin, how are we doing on time? My clock's still saying 0 here, but I think we have to wrap it up pretty okay. So, final thoughts. You mentioned I'm just waiting for the holodeck. Give me a straw poll when, and will it come from industry?
Yeah, I think that the future of 3D is not going to be holography. It's not going to be stereo projections. I think it's going to be a hybrid of technologies, and I'm sure there are smarter people than me working on what that would be. But I suspect that all of this stuff is money driven, and I don't agree with Walter Murch, who's this respected filmmaker guy who said 3D doesn't work, it never will work. He's got some visual problems perhaps perceiving the film, but the notion of whether it's here to stay is really going to be dependent on these large corporations putting their stuff behind it. And we've seen Sony and Panasonic, and just everyone has followed suit. And they have presumably a bunch of guys in suits who predict whether this is going to go or not, right? And whether the millions of dollars. So I think that as long as we're working on it, that could be a very short period of time. But if it falls back, as it's done, 3D entertainment has fallen back so many times, come into popularity, very big in Russia for a long time, not so big in North America for a long time, then it might be a long time coming.
Yep. Ihor, final words on 3D printers. Are they worthwhile, or are they a fad? I think I shared with you that art exhibit in Spain. People could walk into this booth, get themselves scanned, and then by the time they had finished going out of the booth, they were presented with a little GI, or not like army men, or green army men. They were presented with a little figure of themselves, and the exhibit was called Be Your Own Souvenir. So I know you're into 3D printers. Final thoughts on where that technology is going?
Boy, we use it all the time, even in products that we're developing. So for us, a 3D printer for rapid prototyping is invaluable and so cost effective. When we do something like a 3D screen for the iPhone 4, for us to run through 10, 12 prototypes takes less than a week and a few $1,000s. And when we're committing to a $60,000 mold and production, we know that we're going to get the exact geometry, exactly what we need. The fit's going to be perfect. So I think that's going to become an invaluable tool in manufacturing, in medicine, in every area where you need a physical model of something to make a decision.
And fine art, too. When I first saw the online site Shapeways that allows you to take like a 3D model that you make in Houdini, upload it to Shapeways, and like if I was a lamp designer, they can now do glass. When Shapeways brought out glass, it was just, oh my goodness. But the thing that excited me even more than 3D printing with glass, when I first realized you could take a stereo pair, extract a cloud of points, and that originally came from the automobile industry, by the way. Extract a cloud of points, and where am I going with this? Okay, my question for you is, what's the next technology in 3D computer modeling and animation? Like cloud of points made a really big splash in the industry. What's next for the software industry?
Well, for us, for sure, we've always done everything in 3D, so the cloud of points world for sure is neat. I mean, I've got a 99-cent app on my iPhone that lets me scan in 3D, which is, it's freaky, right? That's the future. Yeah. So being able to scan stuff and play with stuff in 3D, model it, print it, that's fantastic. I think one of the big changes is going to be on the output side, and that's going to be the interaction between 3D and higher frame rate smooth motion technology. So I wanted to just touch on that.
We totally forgot. Go for high frame rate displays.
One of the emerging trends that we see, Hobbit being filmed now 48 frames per second, kind of cool, because if you look at what the kids are used to today, it's Flight Simulator, 60 frames per second, that kind of ultra smooth motion. It really changes what people are going to do on the cinematography side. We see it on the animation side. It allows you to reduce the amount of motion blur you're using. I think it's the combination of high frame rate, higher resolution with 3D that's going to be pretty interesting in the coming few years from a technology point of view, for sure.
Cool.
And it'll force everyone to run out and buy a new TV as well, which is always good for hardware manufacturers.
Thank you for bringing up high frame rate displays. That's a key point, and I totally gapped out on that.
One quick
Shawn,
point on the high frame rate.
Yeah, go.
Cameron's point on high frame rate, which I loved, he said, 3D gives you a window into another world, and the high frame rate takes the glass out.
Great analogy. As a post-production person myself, I am terrified about the bandwidth and throughput requirements. 60 FPS 4K stereo,
hey, you're in trouble.
1.8 gigabytes per second sustained, if I did my math right. Eep, like total. Anyway, next steps for IC 3D. Where's that technology going?
There's a few areas that we're really into right now. Obviously, more stuff in medical endoscopy. That's one of my favorites. I love it because I think there's so much useful stuff that's going to come out of there. Another one that's really interesting to me is vehicle driver support systems.
And is that a special case of machine vision?
It is, yes. So it's, again, machine vision, you don't generally use stereoscopy with machine vision. Usually you're using laser or structured light. And it's usually used in labs where everything is known quantities. So it gets really interesting when you take it out of the lab and put it onto a road, probably a poorly maintained road,
right,
in bad weather. You know, what happens to your cameras and alignments and all of that.
And you're not using LiDAR for the scanning, you're using the equivalent of a Microsoft Kinect.
Exactly. So it's one of the areas that we're looking at is, are there applications for, for distance measurement for driver support systems in order to help with things like adaptive cruise control or extra vehicle monitoring and things of that nature, which could really help reduce accidents.
Very cool. Very cool. So that concludes our part of the discussion. I am wide open for questions. If people want to talk about specific industries, specific technologies, any given concepts, we're all up here anxiously awaiting. Crickets, crickets, crickets. Yes, there's a microphone up there. Oh, he beat you to it. You're second. Go.
Hi, I'm Ian Webster. I wanted to ask Shawn about the lens technology that's used in the endoscopy systems that they have developed. Did you guys actually design and patent a lens that will capture 3D, a single lens?
Yes, we have a patent portfolio based around single lens capture.
One more short question about people who wear glasses.
Yes.
So, I saw that the short films, but I have this problem to wear the 3D glasses too heavy, and
yes.
Sometimes I don't want to wear contact glasses because it's bad for the eyes. So do you have any,
For the active glasses systems,
yeah.
It's difficult because of the technology built into the shutter. For passive glasses systems, such as you see in the Real D cinemas, there are companies like Gunnar Optics and the other one that starts with M. Did you see them at NAB? There are companies that are starting to do passive glasses with your prescription built in.
So that means in the glass?
Yes.
Oh.
They apply the polarizing film to your regular glasses. That doesn't work with the active glasses technology, but the active glasses technology is much more simple to set up. So unfortunately, you have to put the active shutters on top of your regular glasses or contacts.
Okay.
But passive glasses, and ultimately no glasses, I think is the direction we're heading in here.
Thank you.
Who's this guy? He doesn't know anything.
One of the things I mentioned to Tom at lunch is this year I spoke at the TED conference, and one of the other speakers was Anthony Atala, who came on stage and printed a human organ in 3D, and that video is just stunning. It's kind of like a cooking show. It went in one end, came out the other, and there he had this. He had a kidney in his hand. It was so that's on TED.com. You can go look at it, and it's a prototype right now. They're not printing money with it yet, but the fascinating thing about it was the printer was only a couple $1,000s, but the cartridge was 10 million.
Somebody's learned the lesson from Gillette.
Typical printer business.
Yes.
I had a question and a comment as well. So my question is, I was interested in the Tetris game used for therapeutic purposes. I just wanted more information on that because I didn't quite catch what was said. What a research.
Yes, the lazy eye.
Yeah.
If you could grab me after, I can give you, I have business cards from the researchers at McGill as well as a little one-page description.
Perfect. Okay. And my comment was, you guys were talking about point cloud data and delivering that content in the web. I'm actually working with Aries 3D. My name is Andrew Salga, and I'm working with Seneca College. I'm working with a project which actually uses WebGL, and it renders 3D point clouds directly in the browser. So it works with Firefox and works with Chrome. So I just thought you guys let you know.
Very cool. Do you have any examples in the Seneca booth here?
Yes, we do. We're at IL 400, and we have a few demos, and we got Connect 2. Working with our point cloud data on the browser.
I honestly think Connect is massively cool because all of us on the high-end 3D animation side have spent an awful lot of time building very high-quality geometry and acquiring very high-quality imagery and mapping it on and rendering it out. And now comes along the Connect, which does crap geometry and crap imagery for $200. And guess what? It's software. There's nowhere to go but up.
Yeah, so check us out. Yeah, we got the Connect working with Firefox. So yeah,
cool.
Take a look. Thanks.
We'll all be around afterwards for a little while if there's no more questions. Thank you very much for your attendance, both at this panel and at the conference.